All right, let's talk about free fall here. Okay? All we mean by free fall is that something is falling close to the earth. Free fall. This is all it means. Free fall. Free fall. All this means is the acceleration is equal to negative 9.8 meters per second squared. When something is in free fall, that means the acceleration is always negative 9.8 meters per second squared. Okay? Which is only we neglect air resistance and all kinds of other things and that's huge to neglect air resistance because actually when things fall when they fall they have a drag coefficient and they slow down. In other words, you have a terminal velocity where something has a drag coefficient. They're slowing down, slowing down, slowing down until they reach zero acceleration. They reach a terminal velocity. They're at a final velocity. They reach zero acceleration, so they're just falling. They're in free fall, but their acceleration is a heck of a lot less than negative 9.8 meters per second squared. That's why some people, you hear about these stories about people falling off of something and they crash through the trees and the snow and they survive. Well, that's because there's things making them fall less than this. But that's all free fall problems are. People get all confused, and now we're going to change because we're going to be in the y-axis. That's all. That's all. We're going to be in the y-axis. Now here's the biggest thing. If I drop something from a height, let's say I've got something up here, and I just drop it, and neglecting air resistance and all other things, I've got an object here, and I drop it. So it's up here at 10 meters. So the initial height is 10 meters. The final height, or y final, is 0 meters. When I drop this, the acceleration is going to be going this way, negative 9.8 meters per second squared. When I drop this, and that means for every second that it's in the air, so it's in the air for 1 second, all right? T equals 1 second. Then its velocity is going to equal negative 9.8 meters per second because final velocity equals v naught times t. There you go. And then now if it falls 10 meters, it won't be in the air for 2 seconds. It's going to be in the air for it's going to be 1.2 seconds or something like that. But anyway, so it's falling, and if it fell for 2 seconds, if an object fell for 2 seconds, then its final velocity would equal negative 19.6 meters per second. It's getting faster and faster and faster as it falls. All right. Conversely, if I throw an object in the air where its initial velocity here was equal to 0, let's say I throw it in the air, it leaves my hand. Here's where it leaves my hand at y equals 0, and then it's going to reach some y final up here. All right, the object's going to reach some y final up here. Okay, but here's its velocity vector. I throw it up with a velocity vector of 19.6 meters per second straight up. Once it leaves my hand, the acceleration is equal to negative 9.8 meters per second squared. So it's going to be getting pulled this way. Here's the acceleration vector, initial velocity vector this way. So it's going to go up after 1 second. T equals 1 second. If I threw it at 19.6, after 1 second, it's going to, the velocity, this is the initial velocity, the final velocity after 1 second, it's going to be 9.8 meters per second. After 2 seconds, I throw it up, subtract where the acceleration is negative 9.8 meters per second squared from it. 9.8 minus 9.8. After 2 seconds, the final velocity is going to be 0, and that's going to be at its max height. Okay? But now let's go back here. Let's go back to where I dropped something from 10 meters. I dropped something from 10 meters, okay? So I drop it from here. Call this y naught is equal to 0. Oh, y final is equal to 0. Jeez. Don't hurry. Y naught is equal to 10 meters. When I drop this, the initial velocity is equal to 0 because I just dropped it. Initial velocity is equal to 0 because I just dropped it. And so then it comes down. It's gaining speed gains. And bam! It hits the ground. What's its final velocity when it hits the ground? It is not 0. Bang! It hits the ground. Because if it was 0, that would, after the collision, like maybe 100th of a second or 25 100ths of a second after it hits, it comes to a complete rest. But at that point, the final velocity is not 0. When it hits, the final velocity, I don't know, we'll have to calculate that. Actually, the final velocity would be very easy to calculate because we can just go, oh, final velocity squared is equal to v naught squared minus 2 times 9.8. I've already factored out the 9.8 there, times 0, y final, minus y initial. And so I wind up with v final squared is equal to 0, minus 19.6 times 0 minus 10, which is minus 10. So that would be v final is equal to 196 meters squared per second squared. Take square root of it. Should be 14, I think. Right around there. Yeah, 14. Okay. There you go. That's all there is to free fall. We make it so darn hard in physics class. Okay? So let's look at one of their problems, and then let's call it a day. Now I'll be on the next one.